Well, hello everybody. Today we're going to be continuing our journey down section 1.2 of our textbook. I figured that today would be a good time for us to practice how to find zones of increasing, decreasing, as well as where functions are discontinuous and what kind of discontinuities they are. So the example at the end of the notes yesterday did get a little bit rushed, and I don't really like that. So I figured what I would do is get you started off on the first question from today's 1.2 practice, discontinuities and slopes. So here we go. You should have this sheet here, and I'm just going to go ahead and walk us through number one here, and you're going to tackle the rest on your own. So here I've got some kind of wild piecewise functions. It's just got stuff everywhere. Vertical asymptotes, horizontal asymptote, jump discontinuities, infinite discontinuities, removable discontinuities. I mean, this thing is all over the world. So what do we have going on? All right, so first of all, where is it increasing? Remember what I said in the previous lesson. Zone of increasing is a place where your roller coaster car would be going up. So remember, we read from left to right, so I would like for you to read your graphs from left to right and imagine that you are riding this curve as a roller coaster. Let's see. Draw myself a little coaster car. Draw myself chilling, having a blast. There we go. Okay, so here we are riding this roller coaster. And what I would like to know is where on this curve is the first time where my roller coaster would be going up, also known as where is this graph increasing, meaning where does it have positive slopes. Well, we can see that Mr. M is going to be falling down the hill here, so that's definitely not increasing. However, once we get past this dotted line here, the roller coaster would be going up. So we could say that the first time that this graph is increasing would be just to the right of -3. So we would start increasing at -3. But when do we stop increasing? We stop increasing right here because, well, this is an endpoint. So we stop increasing at -1. Mr. M, do I put a bracket there? I see that this is a closed point. No, you do not. You never bracket endpoints for increasing or decreasing, ever. Our author disagrees with me, but they're wrong. Okay, and let's see. Right here, the graph is continuing to increase. So throw a little union symbol on there and continue to increase at -1. And we stop increasing. Let's see, that means when does the roller coaster stop going up? Okay, right around there. X equals 1. And again, parenthesis. Why parenthesis? Well, because if you were exactly right here and that's it, frozen in time, let's see the roller coaster got stuck right there. Would you be increasing because you're going up, or would you be decreasing because you're going down, or would you be doing both, or would you be doing neither? You see, because this question is impossible to answer, we're not going to use brackets at the boundaries of increasing and decreasing. All right, how about decreasing? Where is this roller coaster falling? Well, we've already said that over here we're having a blast. Whee! And we do have an arrow right here, which means that forever to the left, I'm going to be approaching this line. So if we imagine the roller coaster was actually way, way, way out there, for the longest time you can imagine, you were slowly going down, slowly, slowly, slowly. So this thing never began decreasing, if you want to say it like that. If you could look all the way out to -infinity to the far, far left, this graph would have been falling, our roller coaster would have been falling all the way until this dotted line, -3. Mr. M, doesn't it shoot down to -infinity? Why aren't you saying -infinity? Because -infinity this way is a y value. When we're talking about increasing and decreasing, we're only listing the x values. We don't care what the y values are. We're just asking in what areas is the graph having certain behaviors. So increasing, decreasing, and constants, all of these things, when you list these range of numbers, they are x values only. Okay. Let's see. So falling forever there. We said this was increasing, increasing. Right here at x equals 1. we begin falling again. And we fall until that open dot. No, you cannot just say you fall forever after x equals 1, because I would say, does the graph exist here? The answer is no. So if the graph doesn't exist here, how could it possibly be decreasing there? So when you have a discontinuity like this, you are going to have to hop over it with the union symbol and then say, yeah, forever after x equals 3, our graph did continue falling. Again, is it falling down towards negative infinity? Yes. But when is it decreasing? It's decreasing after x equals 3. So every x value you could imagine, this graph continues to fall, and therefore it is decreasing. Constant. Constant would mean that this roller coaster was just going left and right perfectly horizontal, and this one is, well, never doing that. So you could write never, or you could write NA, or, whatever. It's just, it isn't. This doesn't have a flat point. Not all graphs will have all increasing or decreasing or constant. Sometimes it's only doing one thing or two things, or, sometimes it is doing all three. This one is never constant. It's either always increasing or always decreasing. And then our discontinuities. Yeah, this one has discontinuities. First one, at x equals negative 3. Because my graph shoots down or up, but this one happens to be down to an infinity, at the value x equals negative 3, we would say that this is an infinite discontinuity. Now, it does not need to go both up and down. It doesn't need to go up. It doesn't need to go to one of the infinities on both sides. Basically, if your graph approaches a y value of positive or negative infinity at an x value, this is an infinite discontinuity. Basically, an infinite discontinuity is a vertical asymptote. And this should be a term that we're familiar with from previous math classes. All right, where is the next discontinuity? Right here at x equals 1. Excuse me, negative 1. X equals negative 1. And because the entire graph picked up right here and jumped up to here, see how I did that? This would be called a jump discontinuity. But then this one here is not a jump discontinuity because the graph didn't literally pick up and go somewhere else. This is as if the point has just been removed from the graph. And that is why at x equals positive 3, we would say there is a removable discontinuity. I do want to clear something up, though, before I let this video come to an end. Let's just say, for the sake of argument, that this point, which has been removed, existed somewhere else. And it really doesn't matter where I draw it vertically. I'm just going to put it down here because why not? What if it had been right there? Is this now a jump discontinuity? No, it is not a jump discontinuity. This is still a removable discontinuity. So what's the difference? The difference between what's going on here and here is that this is a single point in space. A single point has been moved from where it should have been. It has been removed from its appropriate place. Whereas this is an entire chunk of the graph. This whole graph really should have started right here and continued along its merry way. But because it didn't, the entire graph lifted up, or you could have said went down if you were looking at a different picture. But the point is, an entire section of the graph has been moved vertically. And that's what makes this a jump, but this a removable. And I think that's it. You should be able to tackle the rest of this little practice sheet on your own. I will post the answer key to Blackboard. It's not for a grade. It's legitimately just to test your own skills to see if you are getting increasing, decreasing, or constant. And you're going to want to be good at this because did someone say extra credit coming up soon? That's right. You have an extra credit opportunity coming up soon. So make sure that you are good at identifying, increasing, decreasing, constant, and discontinuities. Alrighty, guys. I'll be seeing you soon.